When implementing data shaping functionality, it's important to keep a few things in mind. Data shaping can only happen on resource fields, not on fields that lie beneath that layer. Once a class is shaped, it's no longer of the original type. Working with Expando object makes it easy to create these types of objects. For performance reasons, don't reuse the same method for shaping collection resources as for single resources. The field's parameter must be returned in pagination links, and errors related to wrong input are consumer errors and should thus be returned as a level 400 error. For example, a bad request. I mentioned HateOS a few times. We can use it to adhere to the manipulation of resources by representations constraint. And additionally, we learned that it can also be used for pagination metadata, which will tie into the self-descriptive message subconstraint. Plus, it is a subconstraint in its own right. So it's about time we covered that, right? On to the next module, learning and implementing HateOS. HateOS is an often misunderstood and undervalued REST constraint. Yet, it allows for some really cool scenarios that are very useful in an enterprise environment. With HateOS, client applications can learn how to interact with the API instead of having to hard-code URIs. It also enables a scenario in which a client can automatically react to a business rule change on the server without having to change anything on the client. In this module, we'll learn all about that. I'm Kevin, and I'll guide you through it. So, only one subject this time. Hypermedia as the engine of application state, one of the sub-constraints of the uniform interface constraint. In this module, we'll cover what it exactly is, what it helps with, and how we can implement it in different scenarios. It's quite a big subject, so let's dive in immediately. Currently, our API is already quite good, but it's not exactly evolvable, nor is it RESTful. HateOS will help with this. It makes APIs evolvable and even self-describing. The HateOS acronym means Hypermedia as the engine of application state. In other words, Hypermedia, like links, drives how to consume and use the API. It tells the consumer how it can interact with it. Can I delete this resource? Can I update it? How can I create it? How can I access the next page of data? And so on. But what problem does it solve exactly? Imagine we want to allow the consumer of the API to update or delete a course. Currently, it doesn't know how to do that by looking at the response, which you see on screen here. It has to have some intrinsic knowledge of how our API contract is structured. From the contract or documentation, consumers can learn that they have to send a put or patch request to API/authors/author ID/courses/course ID to update a course with a specific payload, and a delete request to delete it. But it cannot get this information from the response itself. The consumer has to know this in advance, so the consumer needs intrinsic knowledge of the API contract. Now imagine another use case. Let's say we have an additional field, number of available places, on our course. If there are still places available, someone can sign up for the course. In this case, the consumer of the API will have to know it has to expect that field before it can send a post request to, say, API/course reservations. That is again intrinsic knowledge of how the API works, just as in our other example. But say this changes. Say that an additional rule is implemented. There have to be places available, but if the user wants to make a reservation for a course that's marked with content mature, like courses dealing with alcohol, they must be older than 16. This rule will effectively break the consumers of the API at the moment we deploy it. because they have to implement that on their side as well. In short, if an API does not support HateOS, the consumers of the API have to know too much. And if the API evolves, this might break the consuming applications because the assumptions made by those applications can become invalid. And that's the issue that HateOS solves. A lot of these assumptions can be thrown overboard by including links in the response that tell the consumer which action on the API is possible. And those links, well, that's hypermedia. So HateOS allows the API to truly evolve without breaking consuming applications, in the end resulting in self-discoverable APIs. So in our example, we could add an additional property, links to the response. The client would just have to inspect these links. The first link would be a link to get the resource itself. I abbreviated it a bit in the code sample for readability, but this must be a valid URL with the correct host and GUIDs for the author and the course ID. To update a course, in full with put and partially with patch, links are added as well, if that functionality is offered by the API. If deleting a course is allowed, we add a link with the URI and method to delete the course. And if a link to reserve the course appears, a reservation can be made. It's up to the server to decide whether or not to show this link. The consumer needs no knowledge about that business rule, and moreover, the rule can change without having to redo anything at client level. If all of a sudden we expand the rule, stating that there must be places left and the user must be over 16 to reserve a course marked with content mature, this is no longer something that has to be checked by the client. The server would simply not include that link to make the reservation, and the client only has to inspect the link to say, show a button to make the reservation. Let's have a look at another Roy Fielding quote, the guy who coined the term REST. He states that you cannot have evolvability if clients have their controls baked into their design and deployment. Controls have to be learned on the fly, and that is what hypermedia enables. That quote does go quite far. If we match this to building applications, we're almost talking about self-generating client-user interfaces. Most applications don't go that far. But, as the example we used teaches us, for things like rules that can change, this is pretty great. And additional pieces of functionality can be added. For example, marking a course as one of your favorite courses. In that case, an additional link will be provided. This will not break existing client applications, but from that moment on they can implement this functionality, starting from that link. We'll get back to this sample later on. Now, if we think about this is actually no different than how we should work with the HTTP protocol, leveraging hypermedia. REST evokes an image of how a well-designed web app should work. Well, on the web, it doesn't really matter if a link changes. We typically start at the root URL of, say, a newspaper site, and from that we navigate to an article by clicking a link, or we submit a comment through a form. That's two examples of hypermedia driving application state. And if the server decides that the link should change, well, the request that return to root page will contain that new link. Or it won't contain the link at all anymore. The browser, which is our application in this context, doesn't break because that link has changed or was removed. Instead, it's the hypermedia in the response that is used by the browser to show us what we can do next. Okay, now what do these links look like? JSON or XML don't have a notion on how to represent links, but HTML does, the anchor element. In HTML, href contains the URI, rel describes how the link relates to the resource, and type, which is optional, describes the media type. For supporting HateOS, this format is often expanded upon. Let's have a look at one of the links from our previous example again. They all follow the same principles. The method property defines the method to use. REL defines the type of action. This is what clients look for in the links list. And href contains the URI to be invoked to execute this action. The client simply uses this link. It doesn't have to create it anymore. Mind you, HateOS does not completely lift the client of having to have some knowledge of what to expect. It still needs to know about the link types that come back. In other words, the REL values, and whether or not it wants to use them. But we are no longer hard-coding URIs and assumptions in the client. A URI or assumption change no longer breaks the client. And if a link gets added to the response with an REL value the client doesn't know about yet, it ignores that link. Alright, so we now know that HateOS definitely has advantages. But in our examples, we've been working with one author. In other words, a single resource. The links are thus simply an additional field in the response. But what about collection resources? For example, authors. For collection resources, we will need some sort of envelope, an object to hold the value, which is the list of authors, and the links. Were we just to add an array of authors and then a links property, which is an array of links, we'd have invalid JSON. So the result is in the value field while the links are in the links field. This might be the moment when you're thinking, wait a minute, this doesn't make sense. When we learned about paging, we learned that we couldn't use an object like this, with a result field to hold a list of authors and a metadata field to hold the pagination data, because that would break the self-descriptive message constraint. The content of the response doesn't match the content type value in the response header, so the consumer of the API does not know how to interpret the response type judging from the content type. After all, when requesting the authors with media type application JSON, the representation should be an array of authors. What's on screen now is not an array of authors. It's an object with a value field that's an array of authors and a links field that's an array of links. And that is completely true. But this can be fixed. We're covering that in the next module. For now, let's see how we can implement this and answer a few additional questions and concerns about HateOS in the next few clips. In the upcoming demos, we will change our API so it adheres to the HateOS sub-constraint. But how are we going to implement this? The logic for creating the links can't just be automated, as it will depend on the business rules. For example, a course might contain links to update or delete, but also a link that's a post to course reservations, which only appears when some rules are met. That's the sample we used on the slides. We cannot just guess what these links might be for each resource. We will have to code this ourselves. That said, what remains a fact is that we have to add the links to the output. So there should be a links property on each representation we're sending back to the consumer of the API. Essentially, there's two approaches I often see used for this. The first one is a statically typed approach. It involves working with a base class and wrapper classes. getCourseForAuthor returns a list of course DTO. We can ensure that the course DTO class inherits a class that contains links so they can be serialized. And getCourseSysForAuthor returns a list of courses. So that's an action for which we could wrap the results in a containing class so we can include the links. That is a valid approach, but combining it with data shaping will become cumbersome. Remember that we're working with dynamics in that case. And that brings us to the second approach. This one involves working with dynamics and anonymous types. If you look at what we did with the getAuthor action, we know that that one no longer works with the author DTO. It works with an expando object, which is a dynamically typed class. that allows